I suppose a meeting today, 9 o'clock. But and the meeting is an important meeting also. Dean there, we see how we try to speed up, see what time can finish, but definitely not 9. 9 is only 1 hour insufficient. Very busy this semester. And then tomorrow I suppose I have to cancel class, but I think I don't want to cancel. Tomorrow is proposal defense, so very rough. Once I finish your class, then I need to go for quick break, then proposal defense. Okay, 8 o'clock now. How many? I will just start. I just follow the times to be fair for who attended the class earlier. So good morning everyone. We're going to have a test one on 18th April, which is Sunday, 9 p.m. Is it clear? Can you hear me? Yeah, of you? Oh, I forgot to put my. Chris, can you hear me, Chris? So yang lain, dengar kan? We're going to have a test on next Sunday evening, 9 p.m. Lepas tu test itu ada 2 soalan. To be more, ada 2 soalan dan perlu jawab dalam masa 1 jam. You have to get that. You have to submit the answer by 10 p.m. online. So as I told you, there'll be 2 soalan. The first soalan will be from chapter 2 and 3. A scenario will be given, and then you're required to develop the linear programming based on the given scenario. The scenario given, there's almost quite similar to the tutorial that you have done on chapter 2 and 3. It could be a scenario on maximization, it could be a scenario for minimization. Then you have to, based on the scenario given, you have to develop the linear programming. Quite straightforward. It's only a very small portion, a bit tricky. Okay. Soalan pertama. Okay, the second soalan is based on a given linear programming. A linear programming will be given. Then you are required to solve the linear programming using graphical method, which is chapter 4. The soalan? So, by saying so, that's one important thing. Make sure you have the graph paper. Okay. Now, this is for the soalan 2 lah. You need to have the graph paper lah. Please make sure they have graph paper ready for your test 1. Because soalan 2 involve solving a linear programming using graphical method. Ada soalan so far? Tak ada, okay. So by saying so, then the next thing we need to do today is we're going to solve discuss the tutorial. I know some of you might yet to complete because semua dah siap tutorial untuk graphical method. Dah buat. Dah buat?
Dah, doktor.
Dah, bagus. Kalau tak buat pun boleh dimaafkan, Patricia, because the due date supposed to be tomorrow lah. But I decided to discuss today because tomorrow, at this moment, I still don't want to cancel the class. But out of sudden, maybe you'll receive a message saying that, hey, class for tomorrow cancel. And I don't like to cancel class. Today, I have a meeting 9 to 11:30, But I told them that I will join after our class. Then tomorrow, proposal defense. If I cancel, mean the whole week have no class. Okay. So the first thing we're going to do today is everyone clear about the test. I already explained dua soalan, satu daripada chapter 2 dengan 3, satu daripada chapter 4. I would say not really difficult lah. It's only soalan satu, ada satu ayat yang tricky sikit, tapi okay lah. Then today, what I'm going to do today, number one is I'm going to discuss tutorial for graphical methods. Then we'll start discussing sensitivity. Never mind. Sensitivity, chapter 5, it's split into 3. We see maybe we can complete 2, and then tomorrow we do another one. Alright, so kita start lah dengan tutorial discussion. The tutorial is quite straightforward for solving linear programming using so-called graphical methods. For me, it's quite straightforward. There are two tutorials. The tutorial you have, Chris, I can't remember. This tutorial you have developed the linear programming in previous chapter, is it? Yeah, so the linear programming you have developed. Okay. Tak ada orang remind saya record. So this is a video recording for, this is a video. Yes. Sorry, I did not share, is it? Yeah, okay, I'm going to record now. Yeah, I will start record now. So this video is going to discuss the tutorial solution for chapter 4, solving linear programming using graphical methods. All right, so the tutorial number 6, you have developed the linear programming in the previous chapter. I believe it's chapter 2 or 3. So this is the linear programming that you have developed in the previous tutorial. So in this chapter, we are required to resolve this linear programming using graphical methods. The solution to the tutorial is now available in e-learning. I unhide. The solution was there since the semester started, but I unhide a couple of minutes before we started the class today. So to solve the linear programming using graphical method, step number 1, you have to decide the axis. So generally, you're going to use x1 and x2, right? And then subsequently, you have to draw, or you have to develop or define the line for the constraint. And the best way to define the line for the constraint is assume x1 equal to 0 and assume x2 equal to 0. And when we replace x1 equal to 0, what's x2? What's x2? 8. Is it? So if you replace x2 or substitute x2 0 into the constant, x1 will be 10. By saying so, you will get a line 0, 8 and 10, 0. And since this is sort of like carry symbol or a sign of smaller and equal, so the feasible area will be underneath the line. Okay, if you're not sure, you can use 0, 0 to sort of like confirm. So it's underneath the line. You want me to draw it something like here. And then subsequently, doing the same things for the second constraint. You replace, what is that? 0, 0. Okay, so if you substitute 0 to constraint number 2, what you will get? x2? Sorry? Huh? What is it? x2?
6.
6, right? But I heard someone mention different answer. That's why I stopped a little bit. I stopped a while. So, okay, second is substitute x2 equal to 0. You will get
18.
18. All right. So this is another line that you are able to draw. Again, because if smaller and equal, therefore the visible area is D. Lah. And the last constraint here is quite straightforward. X1 equal to 6. X1 equal to 6, which is, what color should I use? This line, yeah? This line. And against X1 smaller equal to 6 means the area must be somewhere here. So by looking on the color that I plotted on the graph, the commonly shared visible area for these three constraints is as I showing now. Okay, and then subsequently, the optimum point will be at the extreme point. So the extreme point we have A, B, C, D. So depends which method you want to use. One of the methods that you should or you could use is to replace A, B, C, D into the objective function. I forgot to ask. Chris, what is the answer that you get? Chris? What's the answer that you get for tutorial 6? Which point is optimum point? What number that you get? X1 equal to what? X2 equal to? Sorry? Forget. Anyone? Never mind, I go to the point. Okay. It's very unlikely that you're going to get the optimal answer is C. Because C, Z is higher. But it's very, very unlikely that you're going to get 3.2. You might get 3. Why? Because this is graphical methods. And then on the graph, it's quite impossible for you to get until so accurate 3.2. So when come to example test or final exam, if the answer that provided by you is 3, I would assume it's right. If you replace 3 into the formula, then you will get Z of, I think, 2700. All right. So my point here is not even the answer scheme shows 3.2, but very unlikely when you get 3.2. Impossible. Because it's graph paper, you see? If you plot it on graph paper. Again, when it comes to your test one, you need to have a graph paper, you have to plot on the graph paper. I know that you can plot graph on many types of software. So this is one method. Another method is you can plot, you can sort of develop the objective functions line, and then you move the line forward using the parent method. And again, C will be the last point that touched by the line, and C is the optimum solution. Any questions for this tutorial? Too quiet. Any question for this tutorial?
Doctor,
Yes, go ahead.
if you use the graphical, the Z line, then there's no working marks, is it? Because we use point, that one we can have the A, B, C, D, the workings, but use the Z, you just moving, then there's no working marks. Step.
Good. Okay, so what need to show in the answer scheme if you are using the so-called the point method rather than the coordinate method? What show in the answer scheme is a coordinate method. So if today I decided to use the second method, the point method, so what you need to reflect in your answer scheme number 1 is this, the original Z line. How you develop this Z line? You get me? Okay, example, you say that I want to start with 2, 0. Then you replace 2, 0 into the objective functions, and subsequently you get another point. And this is the point you need to show the way how you develop the objective function line. Number 1.
Okay.
Number two, you have to draw another line here. You get me, is it?
Yes, I get.
To show that you are moving upwards and this is the last point. The line that I draw here not exactly look like a line. You have to draw another line here. To reflect that, oh, this is the last point that's sort of touched by the line before the line is leaving the visible share, the share visible area. And that is your optimal solution. Is it clear? Is it?
Yeah, it's clear.
Okay.
So
All right.
2 steps.
So the second tutorial is on minimization. Minimization. So you have also developed the linear programming in one of the tutorial that you have done in previous chapter, and this is the linear programming. So nothing new. When I say nothing new means the method that you use to develop linear graphical method is the same. Number one, decides the axis. So it's fixed, x1, x2, then subsequently replace the substitute x1 equal to 0, followed by x2 equal to 0 to identify 2 points that you can plot a line on the graph. So example, for the first constraint, if x1 equal to 0, x2 equal to 6. If x2 equal to 0, x1 equal to 2. So you get the first point here. Where is my pen? Okay. Here is a constraint 1. Then subsequently follow the same methods. Here is quite straightforward, like for 4, like because it's 1x and 1x1 and 1x2. So you should able to develop the second line. And the third line, what is this? If x1 equal to 0, x2 equal to 2. If x2 substitute by 0, it's 6. So you have the third constraint line. And I can't see my pointer. Okay, yes. This is C3. And all of the constraints have the same symbol, which is greater or equal. So basically, these are commonly shared area. And the extreme point, the one that in gray is a commonly shared visible area. And the extreme point is A, B, C, D. So there are two ways. One, you can use the point method, develop the objective functions. But in this case, I would suggest you develop objective function in the visible area, and then moving downwards, and that will sort of like, I need to reflect. There's another line here, and B is the last point that's touched by the line before leaving the visible area. That was the second method that we learned in the class. But most of you like to use first method normally. The first method is identify the point. And in this example or in this tutorial, the point will be very straightforward. There will be no decimal point. I can sort of show you a clue. In your test, most likely you're going to have this type of scenario. There'll be no decimal point. And from there, you replace each of the coordinates into the objective functions. And which is the optimal answer? Which one is optimal answer? A, B, C, D? A, B, C, D? B, like,
B.
okay, you can answer B. You answer B, which is right now, because it's indicated there, like, it's very common, and it happened very frequently in previous semester. Students will happily declare D as an optimum point because you tend to find the maximum value. Okay. Heather, what is that? What have you done this? Have you done this tutorial? Is it?
Yes, I've done this.
What is the last sentence or last portion of the answer that you that show in your answer? The
I
last part of
write
the answer.
I write the minimum cost is $230 when
Uh,
1 gram of ingredient one and 3 gram of ingredient two is used.
yes, correct. You have to do that now. I'm going to show you in the next slide, not next slide, the next chapter. You have to indicate this is another thing that students tend to forget. Whereby happily you read this step and then you perhaps you declare optimum point is B. All right, optimum point is B that is based on the graphic, based on the graph. But what the question want you to do is to solve the model using the graph. So by solving the model, you have to suggest to uh, the company what is optimum solution. So the optimum solution is to what is X1? X1 is ingredient one, is it?
Yes, yes, doctor.
Okay, so it must have 3 unit ingredient one. Oh, no, here it must 1 unit ingredient one, 3 units of ingredient two, and that was sort of like end up with a cost of $230. Okay, you write it in words, man, in words. So that will be uh, the important point. This is the important point because students tend to forget. Okay, so that's it for tutorial. I stopped the recording for tutorial because I don't want to mix it up because this video I'm going to put on chapter 4 lah. The subsequent chapter I'm going to put in video 5. Ada soalan untuk ini? I would say that if you know how to do these 2 tutorials, then it shouldn't have problem for you to answer test 1, test 1, question 2 lah. The thing that you might need to take note is you must practice yourself how to speed up the process of developing the graph and also solving the graph, the problem through the graphical method. Because hanya 1 jam lah. I don't see any questions that abnormal or different from the tutorial. But the thing is, you must be familiar with the approach of solving the method, solving the questions. So you're able to get done in 1 hour time, within 1 hour time. Okay. Ada soalan sebelum ini? Tak ada. Quiet lah. Tak ada. Okay. Danny, okay, Danny, how are you today? Rasanya ada siapa lagi? Zafira, how are you today, Zafira? Danny, your mic problem, okay. Zafira, no. Okay, next we're going to move into a difficult chapter. The chapter we're going to discuss today, this week and next week. For me, it's not based on my assumptions. It's based on the feedback from the student. The chapter we're going to discuss this week and next week are the most difficult chapter in the module. Okay. We're going to discuss graphical method is only sort of like reflect the basic solution. This is called the basic solution. What is the basic solution? Basic solution is what is X, what is Y, and what will be the Z. Or in the previous example is what is X, Y is what table, how many table, how many chair is it, and then what will be the profit. This is called the basic solution. But linear programming will go beyond basic solution. There are many other solutions or many other outputs that you can solve, like will be developed by linear programming, could be developed by linear programming, and it's very meaningful solutions for this industry setting or industry environment. Tetapi because this solution is not basic, it's go beyond the basic solution, so it's a bit complicated. So what we're going to do in next 3 weeks, we're going to discuss the non-basic solution or advanced solution, maybe I do call non-basic. Non-basic misleading. We're going to discuss solution beyond basic solution, how to do it manually, followed by how to get the non-basic solutions or the advanced solutions and basic solutions from linear programming. So by saying so, next week you must have your QA window installed. No? If not, you have difficulty to follow through the class. Okay, kita start dengan the first chapter that related to so-called advanced solutions. For China 825. Oh. Let me open the slide. You see how far we can go. Don't rush, because this few chapter is too rush. Students tend to confuse. What appear on your screen now? Chapter 5, part 1, is it? Okay, chapter 5, part 1. So I'm going to introduce to you two terms that go beyond the basic solution. One is we call it slack, and another one we call it subplus. What are these two? I'm going to take you through. But again, recording. Okay. So this chapter is going to talk about a solution that beyond basic solutions, and I'm going to start with introduce to you to new important terms in linear programming with the name of select and subplus. Very useful variable. Okay. Back to the same scenario. Remember this. Remember, everyone should remember, right? We discussed this in chapter 2. In chapter 2, we discussed Beaver Creek Pottery Sendrian Bahat's scenario case. And then from there, in chapter 2, we developed the linear programming for this company. Am I right, Chris? Remember that? Yeah, okay, good. And then subsequently, last week, we talked about how to solve the linear programming by using graphical methods. As what I explained earlier, the question that I asked earlier on, I say, what was the last sentence that appeared, or last part of the question, or last part of the answer that appeared in your answer script? So don't stop answering the questions by sort of like circle the optimal answer. You have to put in words saying that the basic solution for this linear programming to maximize the profit, the company of Beaver Creek Pottery and Bar should produce 24 bowl, 8 mug, and this will contribute to a profit of 1,360. That is to be the way you answer the question. But again, the answer that show in this green colored box, we call it as a basic solution. Linear programming basic solution is a fundamental. We should go beyond the basic solution. So the next thing that we look into is the next question that we want to explore is at this optimum solutions point, does or do the resources is it fully utilized? Where's the resources? Resources is indicated by the constraint, right? So this is the resources in terms of labor, and this is the resources in terms of the crane. Means at this moment, Beaver Creek Pottery and Bahat, they are 40 hours available, and they are 120 pounds available. So the question is, if the company is producing 24 bowl and 8 mugs, is there any extra resources? Why I didn't sort of like have doubt on does the resources insufficient? I don't worry about insufficient. Why? Because we already put the smaller or equal mark here. So the solution here definitely will not cause any insufficiency in resources, but there's a possibility that the resources is not fully utilized. So how am I going to to check example. We start here first example. This company with 3 operators, there is 40 man hours available. There's 40 man hour available. If the company producing 24 ball and 8 mark, does it mean that the 40 hour is fully utilized? To answer this question, I can use a simple method. This simple method is like this, which is not the final method. I just want to start with the explanation. This is a constraint. Am I right? This is a constraint. At optimum solution, or optimum point, then I replace 24, or x1 I replace by 24, plus x2 I replace by 8. What will I get this from here? What will I get? 40. Oh, this is a perfect scenario whereby at optimum solutions, the company fully utilize the resources in terms of the labor available, 40 hours fully utilized. Oh, that is very great. This is great. I'm not going to show the slide now. Oh, never mind. I follow the slide one by one better. This is a very perfect scenario, perfect solution. But I tell you, in industry setting, this is very unlikely going to happen. Perfect is a nice song, but perfect not easily you can solve like meet a perfect scenario like this in real life. Okay, so what's the next slide show? The next slide is repeat what I explained to you earlier on. If you want to check either the resources in terms of labor is fully utilized at optimum point, you can just replace the optimum point into the constraint equality, constraints constraint formula, and then you can get what's the labor used when the company is produced at optimum point, which is 40, and that is a good news. Labor fully utilized. Okay. If we do the same thing on the second resources, which is clay, I replace 4, 24 plus 3, 8. What will I get? I will get the same answer, 120. 120 means this is really a very perfect scenario, which is will not, and never, in my experience, never happened in the industry. The industry is very unlikely you're going to have such perfect scenario. So if you replace it, you'll get 120. Okay, fully utilized. In reality, I'm going to show you in reality what might happen. And in order to show you, I will move. Example, the company now decided. Example, the company now decided saying that, okay, on top of the labor and the clay constraint, the company decided saying that they only want to produce board. They only want to produce board. They don't want to produce marks. So they only want to produce board. So in this case, this will end up with an additional constraint. What will be the additional constraint? Anyone? This is constraint 1, constraint 2, labor constraint, credit constraint. Now, policy constraint. The company said that, hey, let's say I want to produce 2 products. Why don't I just produce 1 product? In life, or not in life, but in industry setting, it's true. You produce 2 products, very difficult. Why? You need to maintain 2 type skill, 2 production line, okay, 2 line setting. Why don't I just produce 1? The company decided to make the life easy. They only want to produce both. Then this will come up with another constraint. What will be the constraint? If they want to produce both, means what happened to mark? What happened to mark?
0.
0, correct. So this is the easiest constraint in the world. So if from the original solution, if I add another constraint here, x2 equal to 0 here, then the optimum point will become point C. Point C. Okay. Assume that company don't want to produce any mark. So now our constraint point will our optimum point will change to point C. Okay, yeah. From here, I want to answer this. I want to answer the same question that I raised previously. If the company decided to produce 30 ball, why? Because the company don't want to produce marks. And without producing any mark and making a profit of 1,200, what happened to the resources in terms of the labors and the crate? Any unused resources. So I can replace. We'll show in the next slide, but by now you should know me. I don't like just to show you the slide. So example in terms of labor. Now this is optimum point. In terms of labor, I try to replace x1 plus 2x2. Like this is labor. So x1, 30 plus 2x2, 0. End up with 30. Oh, what happened means labor the available in the company supposedly is 40 man-hour per week, if I remember correctly, per week. There are 40 hours available in the company. But the company now is operating in a scenario that producing 30 ball, 0 mark. With this production planning, only utilize 30 hours. So there'll be extra hours of how many hours? 10. So your operator very relaxed, very free. Okay, I don't want to go too far. Look at the slide first. Look at the slide. So if the company produce 30 and 0, 30 ball, 0 mark, constraint 1, I explained it. So it's not fully utilized. Resources that not fully utilized, which is in the level, the unused resources, the unused level 10 hours, and this 10 hour we call it as slack. Okay. So what's slack? Slack is the unused resources. So in solving linear programming, if you know the slack very meaningful, okay, very meaningful, you know that there's resources that are used. You can do something on the unused resources, which is, we will come to that later. And when you say unused resources, mean this 10 hour contribute nothing, no? Contribute nothing to the company profit. Contribute nothing. Since it's unused and contribute nothing, you need to take action on this slack. Okay. And slack in linear programming is representing by S. And in this example, we have two constraints. Constraint 1, constraint 2. So slack is talking about resources. So slack for constraint 1, we call it X1. Slack for constraint 2, we call it X2. Okay. Seems we have 10 hours. This 10 hours is extra hour that we have, unused extra. Not shortage, extra. Therefore, for slack, the symbol for slack is plus. Extra. Okay, what I explained here, what I've explained just now, are also explained in the next few slides. Let's go through the slide. So there are three main points that I try to bring forward. Number one, why we need to identify slack? Because slack is the unused resources and contributes nothing to the company. Therefore, you need to know, is there any slack? If there is, you have to take actions, which is, we'll come to that later. And how to identify slack? The way that I show you now, it's not the best way. The best way is to add the slack, to add the symbol slack into the constraint. So in this case, how are we going to add slack? Slack is representing by S. S1 representing slack for constraint 1, X2 for constraint 2. And it carry a symbol of plus. Okay, I stop here, then I look at the slide. Or I explain here. Unused resources contribute nothing. So here I explain. You can see different, no? I don't know, explaining and reading different, no? Reading, you can't concentrate. Explaining, you can listen. Okay, and then subsequently, okay, here we go to the next slide. So I stop here, like my explanation, I stop here. And the questions that I asked earlier on was, I was saying that the method that I use to identify select maybe is not the best method. So we need to have a better method. This better method is to integrate the X into the constraint. How to do that? This is the way to do that. Is by changing the inequality symbol to an equal symbol. Or in short, basically is add the select into the constraint. By example, this is constraint 1. Add the select in. 1x1 plus 2x2 plus unused resources equal to 40. So now I successfully changed from inequality to equality. So by converting or by adding slack into the constraint, it makes my life easier to find out the slack. Why? I will show you next. So before explain to you how this make my life easier in solving or finding the slack, let's look into what changes happen in linear programming. This is the original linear programming that you developed in week 2. But now I'm saying that select very important. So I want to add select into the linear programming and end up, this is the one. Okay, constraint 1 plus select 1, constraint 2 plus select 2. So another thing that you can sort of like make use as a reference is if the constraint carry a inequality symbol of smaller and equal, then you need to add select. If bigger and equal, you need to add sub plus that we're going to discuss later. And bear in mind, select contribute nothing to the objective function, zero. You have 10 hours, this 10 hours contribute nothing, therefore it's zero. But important thing is not this. This is just want to explain to you. Select contribute nothing. Important thing is this. Okay. We have, by adding the x1 and x2 into the constraint, then you can identify x1 and x2 easily, which is going to show you next. But before I show you next, before I show you how to make use of the x1, x2, let's answer the previous questions. Oh, I'm explaining without asking. So are you still there? Are you still there? How many of you? Still there? That's good. Still there. Okay. All right. Okay, Chris, because today I want to a bit dry. Chris, we identify we identified earlier there's 10 hours. If this is your company, there's 10 hours of 10 hours, 10 main hours that are unused. Okay, so if you are the boss of Beaver Creek Pottery, how are you going to solve this problem? You have 10 unused hours. How are you going to solve this problem, Chris? Sorry? Mm-hmm. Yeah, produce more. You want to sell the 10 hours to someone else. Cannot, like time you can't sell it. Produce more, besides producing more. But producing more is not talking when you want to fully utilize 10 hours. If producing more, the solution will be a bit complicated. You need to get in more labor, you need to bring in more equipment. If we're saying that this is not the best solution, what are the alternatives? What are, no? Are mean more than one. No? Anyone? Oh, yo. If one day Chris become the boss, all of you don't join Chris company, you say you want to retrain, but if you're right, maybe out of the three workers, one of them can sort of like terminate or retrain them. But that shouldn't be the first step, Chris. No, don't do it lah. because because now with the COVID-19, it's not easy to find a job. So perhaps if I'm the boss, I will start with sort of like look into at this moment, my operator are they doing any OT overtime? If yes, then I will sort of set a policy that no OT, no overtime from now onwards. All right. Then If OT still require, perhaps I will set a maximum OT limit. Everyone only can overtime for 1 hour per week, example. So I try to control overtime. Next, perhaps I shorten working hour, or perhaps I sort of like rotating shift. It's very common when this economy is not so, it's unfavorable to everyone. Some company implementing that instead of working 5 days per week, then rotate, you work 3 days per week, then salary will be cut by certain percent. That's better than losing the job, like you reduce, the income is reduced better than. Then if that still couldn't solve the problem, then the next, do what Chris proposed, lay off the worker. So this is something that I might ask you, because for me, study Slack, you can, if you use QN window, like you press a button, in next second the Slack will appear in the table. Finding a Slack is not, or calculating or derive the Slack is not very difficult nowadays with this computer software. But the important thing is understand the meaning of Slack that I explained to you, and what is the implication, what action you need to take with the Slack. That's another important area, and that is the gist of one of the gist of management science. Without studying the Slack, it will just happily produce 30 bold 0 mark, and then the operator will be even more happy because there are 10 hours for them to take a break per week. All right. So for me, this is very important. Important in life and important in exam. I ask you, what is your next course of action that you propose? Clear on Slack. So next, you see, on this clear, we have identified there are 10 hours extra. So now I at least sort of like add in Slack into the linear programming. So it make my life easier in finding a Slack. You see, so you see, now I start to replace. I want to find any Slack for Claire. Okay, right here. Okay, here you get 4, 30 plus 3, 0 plus S2 equal to 120. So 120 plus X2 equal to 120. S2 equal to 120 minus 120 equal to 0. So X2 is 0. So by adding the symbol of X2 here, it makes my calculation easier. Straightforward, I can get X2 is equal to 0. So in this case, there's no unused credit. The company fully utilized credit available in the company. However, there is 10 additional hours. X2 is 0. So understand about this? Fully understand? For this flag,
Yes, understand.
understand. Okay, then we go to the. Hey, what happened to my? Oh, never mind. So then go to minimization. Minimization, which is we use the same example, the farmer example that we discussed in chapter 2. We developed the linear programming in chapter 2, and also we solve the linear programming using graphical methods last week. Using graphical method, and from the graphical method, the solution that we get is the optimal solution for the farmer example is produce or not produce. Don't buy super grow, then purchase or buy 8 bags of crop clips, and by doing that, the cost of purchasing the fertilizer will be $24. This was the solution that we get. So when it comes to minimization, what is a scenario? A scenario saying that the field, the Tana itself requires, example, Tana itself requires 16 pounds of nitrogen for me to tanam jagung, the example I explained. the tanah need to have minimum 16 pound nitrogen to tanam jagung. So I need to make sure that if I put baja on the tanah, then the content of nitrogen must be 16 and above. Okay. But my question now is, I worry that I oversupply. If oversupply rugi, like, in order for me to tanam jagung, I only need the tanah have 16 pound of nitrogen. If I over supply the nitrogen, it's rugi. Because the tanah only need 16 pound. Why supply more? So this is different scenario. It's not unused resources. It's something that a requirement, we exist the requirement that called by the scenario. Okay. So what we worry now is not unused resources. Does the requirement just comply? We existed the requirement. Need 16, but I supply more than 16. So we do the same thing. What we're going to do is we're going to introduce another variable that we call subplus. Okay, so slack is unused resources. Subplus is requirement that existed the minimum requirements. And subplus is also representing by a symbol called x1, x2. x1 for subplus for constraint 1, x2 subplus for constraint 2. However, carry a negative symbol. Why? Because existed the lebih. So I need to solve reduce it. Number one. Number two is how to identify whether that constraint call for a subplus or slack is very easy. If the inequality sign is smaller and equal, then it's a slack. If the inequality sign is bigger, greater or equal, then it calls for a subplus. Okay. This is a way that for you to memorize, but I don't prefer you to do it that way. I prefer to understand. Why subplus? Because oversupply. Oversupply, I must take it out. Slack, unused resources. Unused resources, I must use it plus. Okay. So that is the logic behind. So what I explained to you show in the next few slides. Subplus is an exists above a constant requirement. Macam tadi explain, right? Nitrogen only need 16 pounds. But perhaps I supply more than 16 pounds. And same thing, contribute nothing. The tanah itself, the field itself only requires 16. Kalau 16 pounds, saya dah boleh tanam jagung lah. Why I need to get more? So the one that more than 16, in fact, contribute nothing lah. Contribute nothing. 16 dah cukup lah, maka dah banyak. Okay. And representing by x1, x2, however, negative. Negative. Sampai sini boleh faham? Boleh ya, yang rest? Jennifer boleh faham?
Boleh, Doktor.
Boleh, good. Okay. Next. So kalau macam ni, we're not going to use the old way, we use a new way to find out any subplus. Again, will be shown in the slide, but I don't want to just click the buttons. No meaning, right? For example, if I want to find for, this is what? Nitrogen, is it? Nitrogen. So I replace. The optimum point is, don't buy any super grow, 8 bag of concrete. I replace 2 x10 plus 4 x2 8 minus x1 equal to 16. So 0, 0, 32. 32 minus x1 equal to 16. So x1 equal to? X1 equal to? Yeah, what does it mean? It means that the field itself only requires 16 pounds of nitrogen, but I oversupply by 16. Crazy, right? Wasted, right? Wasted, huh? So, so requirement comply, calculated 16. How about the other one? The other one is here. The other one, phosphate, right? I think. Then is 4, 0 plus 3, 8 minus x2 equal to 24. 24 minus, oh, this is good news. There's no oversupply on the phosphate, right? There's no oversupply. That's good. That's good. So those oversupply, example, the nitrogen, the oversupply existed the requirement by 16. This 16 is called a surplus. Surplus. Clear? Clear? Okay, you need to understand the manual calculation, but just for the sake of understanding and the assessment, when I use this software, in my life, in my experience, I never calculate manually before. You press the button. In my ex company, we didn't use create window. We use other. But if you use create windows and you press the button, the X1, X2 appear there. But now, okay, I want to speak again. Sorry, I asked Chris again. Chris, now I have I oversupply by 16. Now what will be my next course of action? What should I do? Sorry, reduce, but I can't reduce. Huh? How am I going to reduce? I can't reduce because but I buy Super Grow. When I buy Super Grow, example, Super Grow is come along with 2 grams or 2 pounds of nitrogen. If I buy Concrete, it's come along with 4 grams. How am I going to reduce? Or you want to buy Concrete, then you split the phosphate and nitrogen. No, can't that. So what would the next thing you need to do? If this is your company, you already know that. You already know that you buy nothing from Super Grow. You buy 8 bags of Concrete, but this costs you $24 and oversupply by 16. What are you going to do next? But Supergrow cannot. Supergrow optimal solution they call it. No, cannot. You must go. No. Siapa yang nak cuba? You must go up from the box. What you need to do next? Who want to try? Tak ada orang nak try. Zarifa nak try?
Tak sure lah doktor.
Not sure,
Tapi half-half kot. Boleh ke?
Okay, basically macam ni. The next thing I will do is I will ask my purchasing manager. Sebab saya tak boleh control nitrogen. Now nitrogen is controlled by the maker of concrete and Supergrow. So I need to look for the third brain of budget fertilizer, the third brain. I want to look for third brain that with lower content of nitrogen. Lower content of nitrogen, and definitely that will cost cheaper than what concrete offer me. Sebab saya dah reduce nitrogen, so definitely will be lower than 3. So the answer is I sought for alternate brain with lower content of nitrogen. This is where the purchasing manager come to the picture. If this happen in the company, in the industry, then next the boss will call the purchasing manager. Hey, I want to look for the third brand of fertilizer. This third brand of fertilizer must, instead of 4 pounds of nitrogen, I just want to have 2 pounds of nitrogen. So help me to look for a new brand, 2 pounds of nitrogen, 3 pounds of phosphate. And I expect this will be cheaper than $3 or $3. That is what you're going to sort of like derive from linear programming. For me, it's very interesting, this type of number, because in reality, you can't figure out. No, you need to have this linear programming. And when you come to next week, when you use QM window, then you will maybe start appreciate. Because when you key in a formula, you click the button, the X, Y, X2 will appear, tell you, is there any extra resources or unused resources there? Yeah? Okay. Ada soalan nak tanya untuk ini? If not, then the next thing will be the tutorial. Okay. I stop recording. So tutorial, because I want to split between chapters, so I don't want to continue record. So there are two tutorials. Number one, this is the same tutorial that what you have done just now. Okay. So you can based on the tutorial that you've done just now to answer the question, that is there any unused resources if optimal number of chain table are produced? Okay, you identify this. And then if there is, propose the next course of action, what you want to do. This is what you want to do. If there is what you want to do, then this is the same thing, the one that we just discussed tadi kan, tutorial untuk yang chapter 2 dengan chapter 4. Then you going to do the same tutorial. However, the question you're going to answer is there any existed resources? What existed resources? Because this is minimization, perhaps. Then any slack or any subplot. If there is, what will you propose? Ada soalan? Tak ada. Nine, okay. Okay, now kalau tak ada, I will continue one more chapter and then see how far we can go. Bear with me, the next chapter will be more complicated than the chapter we discussed just now. Okay. What appear on your screen now? Okay, let me click the recording button. All right. So now we move to the next chapter, which is chapter 5, part 2, talking about another so-called advanced analysis in linear programming, and with the name of sensitivity analysis. Sensitivity analysis consists of either sensitivity analysis for objective functions or sensitivity analysis for the constraint itself. So in part 2, we're talking about sensitivity analysis for objective functions. And in part 3, we're going to explore sensitivity for the constraint. So what is sensitivity mean? I will not go through these two slides. You will be very confusing because it's all text. Try to explain to you what sensitivity by text, which is I do like. So we're back to the same example. Beaver Creek Pottery Sendirian Bahas. I'm not going to recap. We just explained this a couple of minutes ago. And then this is the solutions. Okay. And at this moment, example, this is my company. At this moment, I'm selling both $40 and mark $50. Okay. Example today, Chris. When I'm in the rush to, I will always ask Chris. Chris, are you there, Chris? If today I decided, I say, hey, I want to change my selling price, like Chris work for me in this company, example. I say, Chris, I want to change the selling price today. From today onward, I want to sell bowl instead of 40. I want to sell my bowl 100. Okay. Which is very common in life, because as I always told you, nothing remains unchanged in life except change. So change is it's anticipated. I would say anticipated uncertainty on the parameter means change will occur. There's nothing remain changed except change. So I decided to change to 100. What will you do? If you are my staff that doing linear programming, Chris. I say, Chris, I decided today onwards I want to change my then my question is, Chris, if I change my selling price to 100, should I still producing 24 ball 8 mark? Should I continue produce 24 and 8? Then what you're going to confirm whether yes or no? What you will do next? Based on what you learn in chapter 1, 2, 3, 4, 5. What you're going to do to give me a exact answer, should I continue produce 24 or 8 marks? Sorry? No, what you want to do? What you want to do? Next. You need to in graphical method mean you need to draw the objective line based on the new selling price. Am I right? So okay, you see originally 40, but now I change to 100. Theoretically, you need to redraw the objective line, change the 40 to 100, and then you try to move the line outward to see whether B is still optimum. Am I right? Yeah, okay. So before I proceed, I want to introduce to you one term, the number here, the selling price. The selling price here, in linear programming, we call these two constants as objective function coefficients. We talk about objective function coefficient, we are referring to the constant for both x1 and x2. Example, objective function coefficient for x1 is 100. Objective function coefficient for x2 is 50. I just want to introduce the term. So you know now you know what is objective function referred to. Objective function coefficient referring to the constant of the variable that under study. Objective function coefficient for x1 is 100. Okay, back to the question just now. If I want to change to 100, then what Chris need to do is to change the line. Oh, change the line to 100 and then move again. You say, oh, boss, no. If you change to 100, then now I'm your boss, that's because you work for me. You change to 100, B is no more the optimum point. The optimum point should be produce 30 ball 0 mark, and your profit will increase to 3,000. Am I right, Chris? Yeah, so you have to develop a new, or you have to plot a new objective function line. Chris, however, if every day I come to the company, I tell you the same problem. Yesterday I told you that I want to change to 100. Today I come in, I say I want to change to 50. Next day I say, Chris, I change to 65. Then another day, Chris, I change to 72. Wow. Just imagine what happened. Every day, Chris is busy plotting an objective line to find out the optimum point. Crazy, right? Okay, so what do you think that will help you? If I can tell you a range, if I can tell you, okay, this is the objective function coefficient for x1. Okay, I call it C1 first. C1. I name it as C1, and I call it C2. C1. You see, this crazy boss every day are changing C1. So what Chris should do is Chris must identify a range. A range, the upper and lower limit. A range that when the objective function coefficient for x1 or kita panggil dia the selling price for both, Chris must identify a range di mana if the selling price is changed from A to B, the optimal solution remain unchanged. Only the Z is changing. I repeat, so to make Chris' life easier, why don't Chris just identify satu range? The range di mana apabila selling price bertukar daripada A sampai B, Chris tak payah plot semula linear programming. Kita tahu if the price tukar daripada A ke B, the optimal solution remains the same. tak tukar. Yang tukar hanya Z. Kalau saya dapat buat macam itu, then it's very great, like wonderful, like Chris, am I right? Okay, so yeah, so this is called sensitivity range for objective function coefficient for x1. I also can identify another range, which is at this moment 50, and this is the objective function. I can identify another range di mana mark harga jualan mark boleh berubah daripada A ke B without changing the objective, without changing the optimum function, without changing the optimum point, but Z will change. Okay, so this is called the sensitivity range for objective function. It's not that explained, but look at the slide. So, oh, I need to erase this one, block the view. So back to the case problem just now. We got a crazy boss. This crazy boss every day like to change selling price. So what Chris should do is Chris should identify a range of both selling price and the optimum solution remain unchanged. So by doing that, he can always refer to the price proposed by his boss, his crazy boss. If still within the range, tak payah tukar. Linear programming. Okay. So this range kita panggil dia sensitivity range for objective function lah. Saya dah explain tadi lah. So kalau you baca, you should able to faham range for the both selling price, objective function coefficients for x1. Sebab selling price untuk both, which is 40 lah, is it? 40x1. This selling price is called objective function coefficients for x1. That optimum solution remain unchanged. Kita panggil dia sensitivity range for objective function coefficients. Okay. So symbol for sensitivity range is CI. Example, sensitivity range untuk XI is CI. Therefore, tadi saya dah I sort of like use it for objective function coefficient x1. I use C1. For objective functions coefficient x2, I use C2. So this is what we want to do. Sampai sini faham? Sampai sini faham? We want to repeat. We want to, okay, daripada minggu 1, 2, 3. Why I change to Malay? When we discuss chapter 1, 2, 3, or 2, 3, 4, like 2, 3, 4, 5, 2, 3, 4. We already developed the linear programming, we already identified the optimal solutions. You even know that the slack, you know the slack, 0. The next thing will be, what is the sensitivity range for objective function coefficient for x1, or what is the sensitivity range for the selling price for the bow, di mana apabila harga jualan bow ini berubah between A sampai B, the optimum solution masih sama. Hanya Z yang tukar. This is what I want to know. Okay. In summary, okay, sebelum go to summary, some of you might go to refer to another book. Chris, you must remind me if it reach 10 o'clock. I don't know what happened to my... Okay. So if you refer to some other reference book, not other reference books, in our module we call it as coefficients of objective function. Some of the reference book or some of the book for management side, they call it as a parameter, they call it as constant. Sama lah nama dia. This 40 ini dalam modul kita panggil coefficients. But in other reference book, maybe they call it as parameter and constant, carry the same meaning. Okay, so apa sekarang? Now it's like this. Kita dah faham? Betul kita faham? Semua faham kan? Sensitivity range for objective coefficients x1, c1 ialah range di mana optimum solution tak berubah. Faham? Faham? Okay, so now the next thing will be how to identify A and B. Betul tak? How to identify A and B? Betul tak? Okay, so the next soalan saya nak tanya, I want to ask is the red color line here showing the objective function line of 40x1 plus 50x2 equal to 1360. Okay, if this is changed to 50, what will change on the line? On the line, apa yang akan berubah pada line? Dia jadi curve. Dia terbalik. What happened to the line? What the line will do? Suddenly change become a curve. No, right? What change? Why shift? Okay, you remember this one? Y equal to mx plus c. What will change? M will change. What's M? The gradient will change, the slope will change, the keturunan will change. So when I change the objective function coefficients, the gradient will change. The gradient will change. Okay, now I start changing the gradient. I change to this. If I change the gradient to this, as what you see in the slide, on the slide. Kalau saya tukar gradient daripada sini ke sini, will the optimum point change? Optimum point change tak? Pasti no, but to convince you, we take a look, you see. Example, I change to this, I start moving this up. Oh, the optimum function, the optimum still point B, am I right? Still point B, betul, Okay, then I change again. I change again. I change to this. I change the gradient to this. I change the line to this. Means I change the selling price again. Will it change the optimum solution? No. B must say optimum solution. Am I right? Yeah. How about I change beyond? Now, I see no change. Then I change until the line is parallel with the constraint. Parallel dengan constraint. Objective optimum solution still remain unchanged. How about I change again? Doesn't change? Are you sure? Now I go beyond the constraint line. No? Tadi ialah sebelum itu ialah saya tukar jadi gradient dia antara original objective line, antara original objective line dengan constraint. Optimum solution tak berubah, antara tak berubah. Saya tukar lagi, I change again until parallel dengan constraint line tak berubah. Sekarang saya dah tukar jadi keturunan dia gradient yang lebih besar daripada constraint. Dah berubah. No more B. No more B. The optimal line now becomes C. What does it mean? What does it mean? It means saya boleh tukar selling price. I can change the selling price without changing the optimal solution selagi keturunan tak terlebih daripada keturunan constraint. You see, I change still smaller than the constraint of the optimal solution still B. I tukar again parallel dengan constraint still B. Tetapi once I over the constraint line in terms of gradient, then the optimum solution change to C. The implication is I can identify A and B based on the gradient of the constraint. So what does it mean? I can change the gradient until parallel with the first constraint. Okay, this could be A or B. Then I change the gradient again until parallel with another constraint. Then from there, I can identify A and B. This is the concept. So this concept faham tak sebelum kita discuss how to do it? Oh, tak ada orang berani cakap faham sebab susah nak faham kan? Faham? Okay, great. Dan untuk case ini dia senang sebab apa? Sebab objective function line is in between two constraints. So dia ada upper, ada lower. Ada case yang tak ada, tapi saya tak nak confuse you dulu. We discuss with the simple case. What I want to warn you is your tutorial 2 will be slightly different from here. I'll let you do the tutorial and we discuss. Okay. So sekarang kita dah dapat confirm bahawa Chris, what is the time now, Chris? Okay. What I can confirm now is that I can identify A and B based on keturunan. Therefore, what is keturunan? What is gradient? Gradient must be identified based on something that you learn in your high school, your secondary school, even your primary school. Or maybe Hazel learned it in kindergarten. Y equal to mx plus c. Or maybe nowadays kindergarten start teaching y equal to mx plus c. You won't feel surprised. Okay, so we have to convert the objective functions and the constraint to the format of y equal to mx plus c. Why? Because we want to know the m. Why I want to know the m is because I know that in order for me to identify the sensitivity range A and B, I need to know the gradient. Once I know the gradient, I can identify the sensitivity range. Okay, so transform Z objective function and constraint into y equal to ms plus c. Don't simplify. What does it mean? I don't simplify. I'll show later. Y. What's y in? Okay, in this case, for this objective function, y representing by no, z is c. What? Why? Or x first. X is x1 lah. Y is x2. We didn't call x2 as y because we're going to have more than 2 variables. See, we can have x1, x2, x3, x4. If I use x, y, z, then what I'm going to use any? I can't use other alphabet z. So z representing c. X1 is x, x2 is y. Therefore, in order for me to convert this into the format structure of equations of y equal to mx plus c, what I'm going to do here is, I didn't do it here, z equal to 40 x1 plus 50 x2. I want to move y to the left hand side, so I move y lah. Y equal to this is y lah. Why I put x2 here? Because y is here, like on my left hand side, equal to, then I start with x1 is this, then followed by, okay, plus or minus z, correct? Minus z is z, okay, z. Okay, z. All right. So, but this is still not in line with y equal to x plus c. Because this is, I don't want 50 x2, I want only y. Therefore, equal to 40, 50 x1 minus 50. Is it in line with y equal to mx plus c? Why? But it's carry a negative. I don't want negative. If I don't want negative, means I just change it. Right? X2 equal to negative plus z 50. So I get that. Okay, I get this. So this is the gradients 40, 50. Don't simplify means don't change to this first. Don't change first. Don't change. If you change, you will get the answer incorrectly. Don't change. This is what I mean. Don't change to this. Okay. So yani that I think this you learn in business mathematics. So I'm not going to repeat this. You can do the same thing on. You need to do the same thing on constraint. Convert x1 plus 2x2 small equal to 40 to the format y equal to mx plus c, and do the same thing on constraint 2. Okay, sampai sekarang paham? Paham, okay.
Faham.
Good. So now, what does it mean? It means even though here showing negative 4 and 5, don't follow. You must use this first. Use this first. Now you already identify the gradients for constraint 1 here, and the gradient for constraint 2. All are negative. Negative, negative, negative. Now the next thing is you try to arrange the gradients from the smaller to the bigger. You try to the biggest, smallest to the bigger. You try to arrange these 3 gradients from the smaller to the bigger. They are all negative. You can just ignore negative, but all of them are negative. I arrange. When I arrange, the smaller is 1 over 2 or 0.5, then followed by 40 over 50, and then followed by 4 over 3. I arrange from the smaller to the bigger. Okay, and what happened is the gradient for objective function is at the center. Correct? Am I right? Please? Okay. Mean this, if this is the case, then this question is very easy. Means, remember here, you have A, you have B. You have A, you have B. Okay. Now we only discussed it. There will be cases that example, when you arrange again, the objective function is not at the center. It's either here or here. In that case, one of the range is without number. But I don't want to confuse you first. We discuss the easier one first. So I repeat, bila dah convert the objective functions and constant into the formats of y equal to mx plus c, then jangan simplify. Dah you dah boleh dapat 3 gradient of kecerunan. Susun 3 gradient ini daripada ascending order, daripada smaller to the biggest. Lepas dah susun, kalau objective function is at the center, then it's good news lah. Your life is easier. If objective function bukan dekat center, ada cara dia juga. Tapi don't discuss first. If not, you will confuse. Tetapi your tutorial 2 ialah your tutorial 2, the objective function is not at the center. Okay. Then dia dekat center, then I can start do the next step. What I do? Okay, you see. Ultimately, apa yang saya nak buat ialah saya nak cari C1 dengan C2. So, saya boleh masukkan C1, C2 ke formula ini juga lah. I can do this. Z C1 X1 plus C2 X2. This is what I want to find. I want to find the sensitivity range whereby when I change from A to B, optimum solution doesn't change. Or I think the slide will show up, correct? Okay. Then if I convert this into the format of y equal to mx plus c, what I will get, I'm not going to write, I showed it. I will get this. Am I right? Betul, right? Okay. Let's start with C1. I think it's better for me to write. I don't want to show the slide first. Start with C1. Sekarang saya nak cari C1. Means from here I cari C1. Kalau saya nak cari C1, C2 saya fixkan dulu. I fix C2. I want to tell it C1. This is C1. This is C2. I want to tell it C1 first. C2 I fix. So C2 I fix first. 50. Langkah ni faham tak? Faham ah? Okay, now I replace this. Equal to ini kan? So C1 sama dengan berapa? 25 tak? Okay, dah. Okay, this is one. Now next, sama. Berapa ada dua kali? Because I want to identify A and B, which is A, which is B later. So another one, kecerunannya sama dengan, why I put kecerunan is equal to it? Because from our previous discussion, we agree that the sensitivity range is when the kecerunan is equal to the constraint. Am I right? So here equal to why? Sorry again, 66 point. Why my eraser cannot use? Alamak, okay lah. 66.67 lah. This is one. Okay, now I want to replace this back. Agak-agak mana, which one is A? Which one is A? 25 lah, the smaller one, correct? And here is, what does it mean? It means, yes, correct. It means Chris boss, which is me, the crazy boss, every day want to change selling price. As far as the selling price is changed from 25 to 66.67, you no need to rerun the linear programming. The optimal solution remain the same. Oh, great, right? Hey, do you think this is very useful? Very useful, right? Very useful. Okay, so we're going to do the same thing on C2. Okay. Oh, sadar, terlebih daripada slide, there's a detail in the slide, but I think you really know me. I don't want to just show like this, you don't understand. Okay, so how about C2? I also want to find C2. C2, right? C2 is the same thing. What is C2? C2 is the range that we're changing selling price from A to B without changing the optimal solution. But the profit will change, yeah? The profit will change. Oh, C2, I do the same thing. What should I do? Because now I want to find C2. Therefore, C1, I must fix it. C1, I fix as 40. I don't use negative, you know why? Because semua negative, right? So I can ignore negative lah. So where is that? C1, C1 40. So 40, C2 lah. Am I right? Right? So first, I replace with this one first. So what is the C2 that I get? Sorry? 80. Okay. So next, I replace this one. 40, C2. What I'm doing now is because I make the gradient in parallel with the constraint. So C2, what I get C2? 30. So now I can replace C2. At the point you calculate, you don't know whether it's lower or upper, but now I know already, lower must be. So done. Means for X2 is marked, is it? It's marked. The current selling price, I tengok answer correct or not first. Correct. Also, what does it mean? It means that at this moment, I'm selling marked at 50. If I decided to change the selling price, as far as I changing the selling price, giving a discount down to 30 or increase to 80, the optimal solution still remain unchanged. It's only the profit will change. You get me? Oh, such powerful solution here is it? Oh, so this is another very, very useful. This is how we use in the industry. We know that you thought that the price is get a plug from the tree. No, the price is basically calculated from here. No, calculate from here. Okay. So by saying so, uh, we done the first part, and you need to do the tutorial. Tutorial one is something that's quite straightforward. Huh? Quite straightforward. I give you the linear programming, then you try to find the sensitivity range for objective functions. Tutorial 2 is the farmer scenario. Tutorial 2 will be slightly tricky because tutorial 2, you might end up with it's only one side. It's only one side. Example, Chris, what's the time now, Chris? Okay, I want to stop it first because I'm supposed to start. Example we arrange. This is your example, this is 40, 50. And then example here is 1, lah. Then 4, 3. Example only. Means, oh, you see the objective function is here. The gradient for objective function is here. It means that the sensitivity range is only have one limit. Means C1, AB. The sensitivity range is only have one limit. Not this, but this. Why not this, but this? Why is this is the limit? Why A is the limit, not B? Why? Okay, this is JB. Example now, okay, we declare, we say that, not we declare, the Datuk Seri Ismail declare, okay, you can travel, you can cross state border, you can melintas negeri, right? Then you say that you can melintas, just example, sorry, short one. We finished the discussion already. I stopped here because I want to cerita Dr. Asri YB Ismail, so I must stop recording. Example government ada satu menteri, ada satu menteri dia kata, dah boleh melintas negeri lah. Lepas tu yang menteri pertama dia kata, you boleh melintas negeri tetapi jangan lebih daripada 100 km. 100 km, 100 km. Tapi tiba-tiba satu lagi menteri dia kata, boleh melintas negeri tapi jangan lebih daripada 200 km. Mana yang nak dengar? You nak dengar 100 atau nak dengar yang 200 untuk selamat? 100. Kalau you melintas negeri sampai 200 km, mungkin dia langkah yang ini kan. So, so that's why this one jangan. Follow this. Okay. So if the objective function is at one side, it means that antara A dengan B hanya satu saja ada limit, another tak ada. Tetapi pada masa ini kita tak tahu sama ada A atau ada B. You need to calculate. You need to calculate. Example in this case. In this case, this limit is here. You dapat 25. Sebab ini dah tak ada kan. So you tak payah calculate ini. Tak payah calculate ini. Sebab ini dah 200. Jangan ambil kira ini nanti tangkap kan. Okay. You dah kira satu. Then only you know that 25 lebih kecil daripada 40. Correct? So you know 25 dekat sini. Then sebab kita dah tahu satu limit, then ini dah tak ada, dia jadi infinity. Oh, tak apa. This one is purposely something like this. I explain to you. For this type of scenario, quite difficult to understand. Tetapi bila you dah cuba buat tutorial, it's okay. My plan for this is I expect you don't know how to do, some of you don't know how to do, but we're going to discuss again in tutorial. So by saying so, I want to end my class now. Then we continue tomorrow. Because let me share the attendance. So untuk siapa yang tadi masuk lambat, right? Our exam is on Sunday pukul 9 sampai pukul 10. Ada 2 soalan, jawab dalam masa 1 jam. Soalan 1, given you a scenario, you develop linear programming, could be maximization, could be minimization. Soalan 2, make sure you ada graph paper. Sebab soalan 2, I will give you the linear programming, you need to solve it using graphical methods. Then let me share the attendance. Maybe I not yet go to the attendance. Where's my... Yeah, okay. What appear on your screen now? Is it the... What appear on your screen? Yeah. Okay. So, section... Either way will do except the graph. The graph you have to write, you have to do it manually. The graph itself, you have to do it. That's why I say you must have graph paper lah. Okay, yeah. You try to think anything you want to ask me about the test, then I can solve lah. We're still going to meet tomorrow lah. Tomorrow, in fact, very rush for me. Today also same thing, still there. I think I show you. Here you see. Hari ni 14, start pukul 9, no. 9, din yang apa, tapi okay lah, need to show you. Tomorrow also same thing. Tomorrow, I have my PhD student proposal defense. The student is at Middle East. So we should start around 1:30. So our class N1, you see, then I thought I want to cancel because I need to discuss with my student in advance a little bit earlier. But I don't like to cancel. But I try not to cancel class. Okay, siapa yang dah scan itu, you can exit because I want to join another